All right, well, good morning, Green Wave. What I want to do now is do some more examples of complete and net ionic equations because I had somebody request a video with a little bit better of an explanation. So let's walk through some more of these examples. So this iron chloride reacts with sodium sulfide to make iron sulfide. That's going to be Fe2S3. That's through crisscross because the iron is plus 3, the sulfide is minus 2. Okay, so you switch places when you write ionic formulas. So it crisscrosses. If you're not sure how that works, we can talk about that privately. I'm going to move on though so as to keep this video a little bit shorter. Okay, so you create iron sulfide, which is a solid. I know that because I look at the Flynn product, the solubility chart, and it comes up as insoluble, plus NaCl. Salt, which is quite soluble. Anyone who's been to the ocean knows that. So I next need to balance this equation, and I'll do that like this. So I have 2 iron here, so let's put 2 iron here. I have 6 chloride, so let's make this 6 chloride. 6 sodiums, I need to have 6 sodiums here, so let's make that a 3. Okay, now I have 3 sulfur, 3 sulfur, 2 iron, 2 iron, 6 chloride, and so on. Okay, so for the complete ionic equation, what I'm going to do is break apart every aqueous substance into its ions. So that's going to look like this. So 2Fe, 3 plus aqueous, plus 6Cl minus aqueous. I get the 6 because there's a 3 here and a 2 here, so it's 2 times 3, plus 3 Na plus 1 aqueous, plus 3 S2 minus aqueous. Let's go ahead and make everything into superscript to make this a little easier to see. Looks like this. Makes Fe2S3 stays as a solid because it does not dissociate because it's a solid, plus 6 Na plus, and that's aqueous, plus 6 Cl minus, and that's also aqueous. Let's make these superscripts now. And let's make these subscript so that they're easier to see. All right, and this is my complete ionic equation. Okay, now let's do a copy and paste to make a net ionic equation, just for the sake of simplicity. So with the net ionic equation, so right here, this is my complete ionic equation. For my net ionic equation, what I'm going to do is get rid of any ion that does not change forms as a result of this equation. Any such ion is called a spectator ion. So, seem to have lost my cursor there for a moment. We can see that the iron, and the sulfur are the only ones that change form. So chloride and sodium are both spectator ions. Sodium and chloride here are spectator ions. So this is my net ionic equation for this reaction. I got rid of the chloride and the sodium because they both did not change form. They both remained aqueous throughout the entire process. So the net reaction is these species come together to make this solid. Let's do another example. So the complete ionic equation for this guy looks like this. So it's going to react to make NaCl, which is again aqueous, plus lithium phosphate, which is solid. All right? My mouse is being a little funny today. Okay? So the complete equation looks like this. Break up everything into its ions. 3 Na plus aqueous plus PO4 3 minus aqueous. Oops, you know what? We did not balance this thing before we started. Let's go back and balance this. Put a 3 here. 3 chloride, need 3 here. Now it's balanced. Now let's go back and do what we're doing. So 3 Na plus aqueous plus PO4 3 minus aqueous plus 3 Li plus aqueous plus 3 Cl minus aqueous makes 3 Na plus aqueous plus 3 Cl minus aqueous plus Li3 PO4 solid. Now, what we're going to do, let's go through these and fix the subscripts and the superscripts to show the correct charges and the correct number of atoms. Alright, so this is my complete equation. So now, let's make a net ionic equation. So, let's do another copy and paste. Alright, what do I get rid of? Well, I get rid of anything that does not change form as a result of this equation. So the Li and the PO4 change form. So sodium I get rid of, and the chloride I get rid of. And you're going to see a common theme where sodium and chloride are typically, or potassium, or nitrates, or things that tend to form soluble compounds, you're going to get rid of when you do these net ionic equations. So my net ionic equation looks like this. Had I written it with the Li and then the PO4, that would have been totally acceptable. Doesn't matter. Alright? We're halfway there. So, let's do the next one. So, barium chloride will react with sodium sulfate to make barium sulfate, which is a solid, and sodium chloride again. You might start to notice a theme here. Just the simple reality is that sodium chloride is very, very common, and chlorides are very soluble, whereas other anions are not so soluble. That's kind of why you see chlorides all the time. All right, so I balanced the equation, so let's now write the complete ionic equation. So Ba plus 2 aqueous plus 2Cl minus aqueous plus 2 Na plus. Maybe I should have taken that typing class in high school after all. Plus SO4 2 minus makes BaSO4 solid plus 2 Na plus aqueous plus 2 Cl minus aqueous. Now let's change some of these charges to be superscripts, obviously, so that we're expressing them correctly, because numbers, superscripts are charges, subscripts are number of atoms. All right, so this is my complete ionic equation. So for the net ionic equation, what I'm going to do is get rid of anything that does not change form. Okay, so I'm going to do this as a copy and paste. So the barium and the sulfate are the ones that change form. These sodium and the chloride I get rid of because they do not change form. These go from aqueous to solid. Nothing else goes from aqueous to solid. Okay, and as my last example, I have potassium sulfate and magnesium chloride. And I should not have done this example because this is actually no reaction. Magnesium sulfate is quite soluble. But you guys don't want to see one that doesn't work, so let's pick one that would work. So let's make this magnesium phosphate. So let's make okay, sorry about that. So now I've fixed it. Now let's make magnesium carbonate instead. So that way we're making an actual product that will be insoluble and you'll have a double replacement reaction. So this is going to make the products KCl, which is soluble, and magnesium carbonate, which is insoluble. All right, magnesium carbonate is a white powder. It's similar to chalk. Okay, so now the complete ionic equation will look like this. Wait, first we check to see if it's balanced, which it is not. We got to put a 2 here. Okay, now the complete ionic equation, 2K plus aqueous plus CO3 2 minus aqueous plus Mg2 plus aqueous plus 2Cl minus aqueous makes 2K plus 2Cl minus aqueous plus MgCO3 solid. We are going to change these into superscripts. Make these as subscripts. Okay, so this is our complete ionic equation. So then finally, to make the net ionic equation, what I'm going to do is eliminate anything that does not change. Okay, so my net ionic equation, potassium does not change, the chloride does not change, but the magnesium and carbonate do. So my net ionic equation will look like this. So now I've gone through 4 different examples of net ionic equations. Whoops, let's fix that. Should be a subscript. And I hope this has been somewhat helpful. I really do wish I could be there in person to walk you through these things, but this is what it is. I'm trying to make the best of it. So if you do have more questions, please don't hesitate to ask. Whoops, I did notice another thing. This should not have been superscript, so that should be Cl minus. If you have any questions, please don't hesitate to ask. But otherwise, I will look forward to teaching you more chemistry as this semester continues on. All right, this is Mr. Brisky signing off.